Well, thank you all so much for coming today. If y'all haven't seen me around already, I'm Ryan Murphy. I'm the current president of the student affiliates of the American Chemical Society. This is Kristen.
Hi, I'm the current treasurer.
And so what we're going to do today for our demo show, we're going to take you through a typical day in the life of Blaze the Dragon, our mascot here at UAB. Blaze is a proud member of SAACS at UAB, and he has a lot of science going on in his life that we're going to kind of share with you all in this presentation. Blaze starts his day, like all of us, waking up in the morning. And when Blaze wakes up, he's very drowsy, like a lot of humans I have. So when Blaze wakes up, he gives a big, strong dragon yawn to kind of wake up in the morning. And when Blaze yawns, his yawn is really powerful, because Blaze has what we like to call dragon breath, so it makes the breath really, really strong. Now, Blaze actually learned how to do dragon breath from a scientist, Bernoulli, back in 1738. And Blaze actually taught me how to have dragon breath as well. So, for this first demo, we need one volunteer from the audience.
Let's see, in the back in green. Straight up. Yep. No, you're looking around. Yes, yes, come. Take about 2 steps back. Perfect. Okay.
All right. So what we're going to do in this first demo, before we started the show, Kristen and I were having a little argument. She doesn't quite believe that Blaze actually taught me how to use dragon breath. So she challenged me to a little competition here, and we're going to see who can blow up the bag the quickest. All right. So when you give us the signal, we'll start.
Ready, set, go, whatever you want to say.
I think my breath speaks for itself.
Fine. Okay, whatever.
Thank you so much for helping us out.
I'll take those.
Surprise for giving us a little help. Thank you. 2 more rounds of applause. Now, does anybody know the secret behind my dragon breath? Why I was able to blow up the bag so much quicker than Kristen was?
Because you stood back a little bit and had more area to blow, directed straight from out.
That is a very good point. That's exactly what was happening. So, to explain it a little bit more in depth, what's going on there, when I stood back, I was acting on Bernoulli's principle. Now, what Bernoulli's principle is saying is when you have an area of high pressure air, it wants to bring in low pressure air into the same area. So when we were both blowing into the bags, so when I stood back, the breath coming out of my mouth was a stream of high pressure air. So it was pulling all of the low pressure air in from the surroundings and bringing it into the bag. Now, when Kristen was blowing up the bag, she took the approach of blowing it up like a balloon, getting her face close to the bag and blowing it that way. Now, when you do that, you don't have all the surroundings to bring in the low pressure air, so it takes a lot longer to blow. And so now, y'all all know the secret behind dragon. Now, once Blaze wakes up and he yawns and he has his coffee and he starts romping around, starts to make a ruckus that dragons do, before Blaze can start breathing fire, he has to kind of heat up and get ready for his day. So we're going to kind of simulate what would happen if Blaze held water in his hand while he was all heated up. I'm going to need another volunteer for this one. So what we have here in this next demo, this is called a hand boiler. It's just glass. It's got a bulb on the bottom, a bulb on the top, and a glass straw running up to the top. Now, what I want you to do, we're going to hold it up. I want you to take it in the palm of your hand. Just hold it. Sometimes it takes a while. Go ahead.
There you go.
My hands are super warm. Blaze kind of rubbed off on me.
Not quite, but you guys saw sort of what happened, right?
So this is still a good principle. It's still a good difference. So your hands are a little bit colder, mine are a little bit warmer, so y'all can see the difference that happens. We have a warmer palm. Makes the liquid go up. Now it looks like it's boiling at the top, doesn't it? With bubbles. Thank you so much for your help. Let's give her a round of applause. Now, does anybody know what principle the hand boiler is acting on here? I'll give you a hint. The water is not actually boiling. I'm not as hot as a dragon. That's a good point. So temperature is definitely a big factor in it. And actually what we're acting on here are some simple gas laws with volume, temperature, and pressure. So when you look at the hand blower, since it is a glass apparatus, the volume is going to stay fixed. The container isn't going to expand at all. Now when I put my palm on it, I'm introducing heat. Now when the heat raises, the volume remains constant. It's going to up the pressure of the gas in the bottom bulb. So it's going to push that liquid up to the top. Now what you see that makes it look like it's boiling? In the bottom bulb, there's not very much liquid. So it keeps forcing up air into the top bulb, which just makes it look like it's boiling because it keeps forcing bubbles up through the bottom of the liquid.
And you reverse it.
So to reverse it, you just put your palm on the top, send it back down to the line. Well, now the blaze has really got started going, start breathing fire, get things started right. Now I know y'all probably already saw this outside. This is our methane bubbles experiment.
I say if you have it, you can see it now.
So, what we've got here is methane gas in beach ball. We get the methane gas from here in the chemistry department. So what I'm going to do, this bowl right here is just a solution of soap and Dawn dish soap. So I'm bubbling the methane gas into the dish soap, so it's getting caught in the bubbles. Now, there's two properties of methane gas that are really important here. One, methane gas is very flammable. Two, methane gas is lighter than the air that is around us. So, when it breaks out of the bubbles, it's going to want to rise up towards the ceiling. So, what we're able to do so basically, you can catch the bubbles in your hands, and we can light it on fire in Kristen's hands, and it actually won't burn her. Because the gas, once it breaks out, like I said, it's going to rise up. Now, one important thing to remember, you want to wipe the bottom of the hands, make sure there's no bubbles there, because if those get lit on fire, those will rise up in the hands and singe the air up back here. And this is one we, of course, recommend that y'all do not do at home. It's harder to get methane gas. You don't want to deal with that, but it is cool to see that it is safe when in the right environment. Now, once Blaze has started breathing fire and causing a ruckus, as the day goes on, he gets hungry. Blaze wants some food. Now, if y'all know anything about goats, goats will kind of eat whatever they can eat. They're kind of like the garbage disposals of the animal kingdom. Well, dragons are pretty much the same thing. Dragons eat a lot of really weird stuff because their stomach acid has all sorts of weird chemicals that will dissolve a wide range of material. And one of Blaze's favorite foods, oddly enough, is packing peanuts. I don't really get it. I don't think the flavor is that great. Blaze loves them, so we let him do what he wants. Now, one of the components of Blaze's stomach acid that allows him to dissolve those packing peanuts is acetone. So what I'm going to do, I'm going to pour some acetone in the clear bowl here. I'll move it forward so y'all can see it a little bit better. So right here, I just have a normal block of styrofoam, polystyrene. So watch what happens when I dip it in the acetone. So it starts to dissolve it pretty quick. If I leave it sitting in the acetone, it'll just keep bubbling and it'll dissolve the whole block. So one of the big questions that remains with what was going on there, so y'all saw I started with a fairly decent sized block of styrofoam. And as I pushed it in the acetone, it kind of just formed into like this little bit of goop suspended in the liquid. So the reason that happens is because of what polystyrene is actually made of. So when you look at styrofoam, there's polystyrene is one of the main components. There's one other main component. Can anybody tell me what the other big component is? In the red shirt. Air, that is exactly right. So, with polystyrene, air is one of the big components. So what they actually do when they're making styrofoam, they take the plastic, the group that you see there in the bowl, and they basically bubble air into it to get it to increase in mass and get the normal styrofoam that you usually see. So since styrofoam is soluble in acetone, When we push it into the liquid there, it starts to release all that air that was trapped in the plastic, which is the bubbling that you see, and it condenses into its original mass of just the plastic. The other thing to know about Blaze, he loves science, but Blaze is also kind of a little bit of a trickster. So he likes to have fun with chemistry and cause a little bit of mayhem. So what we're going to do here, we're going to do one of Blaze's favorite experiments, and I'm going to need one volunteer for this one. You want to pick someone?
Alex, you want to come up? Good. You, bright green shirt, right?
All right, so I want everyone to watch me carefully. I've got 2 solo cups, right? I've got another solo cup of water in it. I'm going to pour some water in each of these solo cups. Y'all saw me, no trickery, I poured water in both of them. I'm going to mix them up so we don't know which cup is which. All right. Now, so what Blaze likes to do this little trick where he gets these 2 cups and he does this, and he likes to pour the cups on people's heads and see what happens. So y'all ready?
I'm lucky.
You got lucky.
Yep.
Thank you so much for your help.
I get
Let's give a
wet.
round of applause for this. So Blaze can be kind of mean. That wasn't a really nice thing to do, Kristen, but it is weird, right? Why did water come out of one cup but not out of the other? So let me ask y'all, when y'all were rotating through the demo stations, did y'all see the experiment Instant Snow? I think y'all were saying it was one of your favorite experiments, right? So do y'all know what Instant Snow is made of? Anybody remember? Youth Bracer. What now? That's close. That's very close. So what it's actually made out of is a super absorbent polymer. And I think if y'all went by the station, what y'all would see on the canisters, it says snow polymer. But it's actually sodium polyacrylate. So sodium polyacrylate is a polymer, it's a long string of molecules, and basically it's a super absorbent polymer that can absorb large quantities of water, much larger than the mass of it. So if y'all look at the bottom of this cup, you can see there's kind of a goop accumulated at the bottom. So that's because the sodium polyacrylate absorbed a lot of water. Now I tried to do something earlier and I didn't use enough water to make it work, but if you pour a whole lot of water in and then you add some salt, it'll actually release the water from the molecules. And so when you think about one of the applications of sodium polyacrylate, it's found most commonly in diapers. And so it can absorb a wide range of liquids. It can absorb something like distilled water that has no ions in it, tap water that has some ions in it, or a liquid like urine that has a lot of ions in it that are being transferred out of the body. Now, depending on how many ions are in solution is going to determine how much water the sodium polyacrylate can hold. Because when it holds the water molecules between the polymer strings, if it has other ions taking up that space, it's not going to be able to hold as much water. So when you add salt to it, you're usually able to pour it back out and dump water in somebody's head again. But I'm a little bit nicer than Blaze. I'm not going to pour water in Kristen's head again. Now, after Blaze has had his fun and his trickery and his mayhem, he gets tired and he needs to go to bed. So before Blaze goes to bed, he does what all of us should do, brush our teeth before bed. So with this next demo, we're going to be making some dragon toothpaste with our elephant toothpaste experiment. Have any of y'all seen this one before? So we got a couple of people. I see some nodding. So for those of y'all that haven't, this is going to be pretty cool. It's a neat reaction. So I'll go through and explain the steps. In the bottom of this container here, I just have some Dawn dish soap. Now along the sides, I'm going to drip some food coloring just to give it a little bit more color, make it a little bit more exciting. Now the main reaction that's going to be happening here with this experiment is the breakdown of hydrogen peroxide. Now when hydrogen peroxide breaks down, it breaks down into water and oxygen gas. Now most of y'all probably have hydrogen peroxide in your homes, just normal 6% solution, probably somewhere in your medicine cabinet or whatnot. Now the type of hydrogen peroxide I'm going to be using today is a lot more concentrated. This is 30% hydrogen peroxide. It is a bit more dangerous. It will burn when it hits the skin. I actually kind of burned my finger a little bit earlier, but that's okay. So this is not your normal household hydrogen peroxide. I'm also going to be using saturated potassium iodide, which is going to serve as a catalyst for this reaction. Can anybody tell me what a catalyst is for a chemical reaction? So an enzyme can definitely be a catalyst for a reaction. So what a catalyst is it's a chemical that participates in the chemical reaction like an enzyme, but it doesn't actually get absorbed by the reaction. It basically makes the reaction proceed quicker, but it doesn't actually break down or change chemically. So this is going to accelerate the breakdown of hydrogen peroxide into oxygen gas and water. So what I'm going to do is I'm going to pour both of these into the container at the same time. And hopefully all this oxygen gas is going to be caught in the soap, and we're going to see a pretty cool reaction. I'll give you all a countdown before I pour it, so if you want to take pictures or video, you can do that. Give you all a second to get set. All right, everybody ready? All right, 3, 2, 1. That's a good question. You should not touch it. Now, can you all see the steam that's rising off these bubbles that came out? So this is one of the reasons we call this like the dragon toothpaste, because of how hot it is. The reason it's hot is because this reaction is an exothermic reaction, meaning that as the reaction proceeds, it releases a lot of heat. So it wouldn't be a good idea to touch the bubbles because they would be pretty hot when you touch them. Well, now that Blaze has brushed his teeth and he's all ready for bed, he's going to do one last demo to remind everybody he's the biggest, baddest dragon around. That's with his roar and powerful flame. This is our whoosh bottle demo. Y'all probably saw this outside, but if you didn't get a chance to. In the bottle here, we've let isopropyl alcohol sit at the bottom of the bottle for about an hour. It's accumulated alcohol vapors inside the bottle. So when I pour the alcohol out, all that's left is the vapor. And when I light it on fire, you're going to see the flame travel down the bottle, and it's going to make a cool whooshing sound. All ready?
What's with
Thank you all so much for coming today and watching our demo show. I'd like to give a brief shout out to two of our most generous sponsors, Progress Bank and East Davis. Both of these sponsors gave so much money to help us out with this event and provide all the demo supplies that you've seen for everything that we've been able to do. So it's been really fantastic to have their support along with all of our other sponsors that are listed in your goodie bags. If you want to keep up with what we do with SAACS and UAB, you can follow us on Instagram, Twitter, and Facebook. If you have any questions about anything that we do or any events that we do, feel free to email us. This is my email right here, our Vice President Emily's email there, and our organization email right here. But other than that, thank you all so much for coming. If you have any questions, feel free to come up afterwards. But otherwise, have a great rest of your day.